Welcome to Arizona State University's University Academic Center. This is an example video for the topic on and or with Venn diagrams. We use and or in set notation, set theory, some statistics, and talking about Venn diagrams. You can also use the words union and intersection, and you might have heard those terms in class too.
Is the meaning same in English as it is in math?
Not really. Here's a definition of and from dictionary.com. Used to connect grammatically correlated words, phrases, or clauses, along or together with, as well as, in addition to, besides, also, moreover. An example would be pens and pencils. In other words, all together. An example is, I would like to eat all the ice cream and chocolate in the house. I'm saying I want to eat everything that has chocolate and ice cream, even if they are combined. In math, the meaning of and means only what is in common with both. So back to the example. I would only eat ice cream if there's chocolate in it. I would not be eating anything that wasn't ice cream with chocolate or chocolate and ice cream, what you want to combine that as.
Okay, so if I say I am not going to eat anything that has honey and nuts, in English it means I will not eat anything that has honey and anything that has nuts, and really would include food that has both. In math, it is like saying that I am not going to eat anything that has both honey and nuts in it. Am I understanding this correctly?
That is correct. Now let's go to or. Now or, from dictionary.com, used to connect words, phrases, or clauses representing alternates. Some examples would be books or magazines. Another one would be to be or not to be. This is meaning you have to pick. It is one or the other, not both. Let's look at the same example but change it to or. I would like to eat all the ice cream or all the chocolate in the house. I would like to eat one or the other. I do not want both. Whatever I find first will work. In math, it means all that has one or both in it. So back to the example, I would eat all that I can find.
So, if I say I am not going to eat anything that has honey or nuts, in English it means eat something if it only has one but not the other. In math, it is like saying that I am not going to eat anything that has honey or nuts in it. It seems like in math, and or, the meaning flip compared to English. Am I saying that correctly?
Your example was awesome, and yes, you are saying that correctly. The meanings of and or flips for math. It takes a little bit to put your head around it. If it takes you a while to assess it, it's okay.
What helped you to understand and remember this better?
I think what helped me the most was practicing problems that was dealing with and or. Do you want to do some examples?
Yes, please.
Here we go. This is the example we'll be working with. There was a survey that went out to some of the people that was working at the Arizona State University's University Academic Success Program during summer 2017. Asking, do you prefer to get caffeine from coffee, tea, soda, or none of the above? Here are the results of 22 people. 16 people like coffee, 3 people like coffee and tea, 2 like all, 4 people like tea, 2 people like soda and tea, 3 people like coffee and soda, 3 like none, and 5 people like soda.
I want to say that we can start by making a Venn diagram for we can see what is happening with the data. This is one of the parts I have difficulty with. My numbers never add up to be the number of people in the data, but it's always way more.
Okay, let's work through making a Venn diagram together. How many circles do we need, and what should we label each circle?
We need 3 circles. We can label C for coffee, T for tea, and S for soda. After this, we put each number we have in the circles.
Close, but before adding the numbers into the circles, please add all the numbers up now.
Okay, 16 plus 3 is equal to 19, plus 2 is 21, plus 4 is over 22. See, my problem is, they always go over the number of people.
Yes, but did you realize you are counting people more than once? When you are just looking at numbers, if someone likes all 3, they could be counted in the single one of coffee.
Oh yes, they can. Is this why my teacher says to start in the middle and work out?
Yes, it could. There are only 2 numbers that we have, and we do not need to change. The first one is the none, the NA. They go on the outside of all the circles because they don't like any of the 3, so we still need to count that in our universe, but we don't put it in a circle. And then we have the all, the people that like all 3. So that goes where all 3 circles overlap. What do you think we're going to do for the people that like 2 out of the 3?
Could we take the number we were given and subtract the number of people that likes all 3?
That is correct. Great job. The people that like coffee and tea and coffee and soda will get 1, and the people that like tea and soda, we will get the result of 0.
Do we do the number we have and subtract it by 2 for the people who only likes one item?
Close. You are forgetting the one that likes 2. So we are going to use the number we like minus 2 for all minus the numbers for the people that like caffeine 2 ways. For example, coffee would be 16 minus 2 for the people who prefer all 3, which is 14 minus 1 for the people that like coffee and tea, and that is 13. And finally, we minus 1 for the people that like coffee and soda. Again, we get the result of 12. What would the numbers be for tea and soda?
For tea, there is 4 minus 2 minus 1 minus 0, and that will be 1. Now, for soda, it will be 5 minus 2 minus 1 minus 0, and my result is 2.
Good job. Both results that you calculated looks good here. Let's check. All the numbers should add up to 22.
3 plus 12 plus 1 plus 1 plus 1 plus 2 plus 0 plus 2, which equals 22.
Now let's answer some questions using and dash or with the Venn diagram we've put together. 1. What number of people drink tea and soda to get a caffeine kick?
And in math, it means only what is common in both, so the answer will be 0.
That is correct because it says tea and soda, and you don't count the 2 people who also like coffee. Number 2. What number of people drink coffee or tea to get a caffeine kick?
This one is all the people like coffee, tea or both. If they also like soda, not a big deal. Am I thinking this correctly?
I think so. You counted everything in both circles of coffee and tea.
So that would be 12 plus 1 plus 1 plus 1 plus 0 plus 2, and that's equal to 17. Cool. Can I have a couple more to practice?
Yes, you can. Try. intersection of coffee and tea.
What is this?
These kind of problems can be done just by using symbols. The upside down U means and. What do you think the question's asking you?
What number of people drink coffee and tea to get a caffeine kick?
Correct. And so your answer will be 1?
Yes, it will be.
What about this next one? Number 4. Union of soda and tea.
I am guessing that the U means or. The question is asking what number of people drink soda or tea to get a caffeine kick.
That is correct. What is the answer?
I am going to do 1 plus 2 plus 1 plus 0 plus 1 plus 2 and it will come up to 7 people.
Good job. I think you might have this. Just keep practicing, and before you do, what part do you feel is the most important to remember?
It helps to see the data in a Venn diagram, and with the Venn, work from inside out and do not count the people more than once. Then, when I am answering question, remember and or in math means the opposite than they do in English.
I agree. Those are very important to remember. You did awesome today. Thanks for coming and have fun.